Antimatter, a term that sounds like it belongs in the realm of science fiction, is indeed one of the most fascinating and perplexing concepts in modern physics. It represents a form of matter that is the exact opposite of the matter that makes up everything we see around us. For every particle that exists in our universe, there is a corresponding antiparticle that has the same mass but an opposite charge. For example, the antiparticle of the electron, which carries a negative charge, is the positron, which carries a positive charge. This symmetry between matter and antimatter is not just a scientific curiosity. It holds profound implications for our understanding of the universe, the fundamental laws of physics, and the future of technology. One of the most astonishing facts about antimatter is its rarity in the universe. While matter is abundant, forming stars, planets, and living organisms, antimatter is exceedingly scarce. In fact, when scientists attempt to create antimatter, they find that it is produced in minuscule quantities. For instance, particle accelerators can produce only a few nanograms of antimatter at a time. This scarcity raises intriguing questions about the origins of the universe. The prevailing theory suggests that during the Big Bang, equal amounts of matter and antimatter were created. However, for reasons still not fully understood, our universe ended up dominated by matter, leaving antimatter as a mere trace. The annihilation of matter and antimatter is another remarkable aspect that captures the imagination. When a particle of matter encounters its corresponding antiparticle, they annihilate each other, releasing an enormous amount of energy in the process. This reaction is described by Einstein's famous equation, E = mc2, which illustrates the equivalence of mass and energy. The energy released in such annihilation events is far greater than that produced in any chemical reaction, making antimatter a potential source of power that could revolutionize energy production. Just a tiny amount of antimatter could yield energy equivalent to that produced by traditional fuels, raising the tantalizing prospect of antimatter as a clean, virtually limitless energy source. However, the current challenges in producing and storing antimatter make this a distant dream. The implications of antimatter extend beyond energy production. In the field of medicine, positron emission tomography, PET, scans utilize the principles of antimatter to create detailed images of the human body. In a PET scan, a small amount of radioactive material emits positrons, which, upon encountering electrons in the body, annihilate and produce gamma rays. These gamma rays are detected and used to construct images of metabolic processes, allowing doctors to diagnose conditions such as cancer and heart disease. This application of antimatter illustrates how even the most exotic concepts in physics can lead to practical advancements in healthcare. Moreover, antimatter plays a crucial role in our understanding of fundamental physics. The study of antimatter has provided insights into the symmetry of the universe and the laws that govern it. For instance, researchers have investigated whether antimatter behaves differently than matter, a phenomenon known as charge parity, CP violation. Experiments conducted at facilities like CERN have shown that certain processes involving particles and their antiparticles do exhibit slight differences. This asymmetry could help explain why our universe is predominantly composed of matter, despite the initial conditions suggesting a balance between matter and antimatter. Understanding these differences may unlock answers to some of the most profound questions in cosmology and particle physics. The potential for antimatter to contribute to space exploration is another area of excitement. The idea of using antimatter as a propulsion system for spacecraft has been proposed, as its energy density is vastly superior to that of conventional rocket fuels. If harnessed effectively, antimatter could enable spacecraft to travel at significant fractions of the speed of light, opening up possibilities for interstellar travel. While this concept remains theoretical, the exploration of antimatter in this context pushes the boundaries of our imagination and challenges us to think about the future of humanity beyond our own solar system. On a philosophical level, antimatter challenges our understanding of existence itself. The very fact that our universe is predominantly composed of matter raises questions about the nature of reality, existence, and the fundamental laws that govern it. The imbalance between matter and antimatter invites speculation about the nature of the cosmos, the potential existence of parallel universes, and the limits of human understanding. As we delve deeper into the mysteries of antimatter, we are compelled to confront the limitations of our knowledge and the vastness of the unknown. Yet, with all its promise, antimatter also poses significant challenges and ethical considerations. The production of antimatter requires immense energy and sophisticated technology, raising questions about resource allocation and environmental impact. Furthermore, the potential for weaponization of antimatter, given its incredible energy release upon annihilation, presents a grave concern. As we advance in our understanding and capabilities, it is crucial to approach antimatter with caution, ensuring that its applications are guided by ethical considerations and a commitment to the betterment of humanity. In conclusion, antimatter is a captivating subject that bridges the gap between the realms of theoretical physics and practical applications. Its rarity, the potential for energy production, its role in medical imaging, and its implications for our understanding of the universe are just a few facets of its significance. As we continue to explore the mysteries of antimatter, we not only expand our scientific knowledge, but also engage with fundamental questions about the nature of existence. The journey into the world of antimatter is a testament to human curiosity and ingenuity, reminding us that even the most elusive concepts can lead to profound discoveries and advancements that shape the future of humankind.